So, hello friends, how are you all? I hope you are all good and healthy. So, let's once again, I'm welcoming you all in this interesting, technical video in which you will come to know the facts, the working, the technical details of fan regulator. So, this is one of that device, guys, that is used in every single household, and you all are very much familiar with this. So, this is nothing new, but the functioning and the working, that is the side something you don't know, this is going to be revealed today in our video. So if you have not subscribed to us till now, then it's a request, then please do subscribe and watch this video full and share this if you like this. Okay, so now let's start this video. So first of all, let me show you that how this fan regulator looks. So this is one of the fan regulator. It is the one of the regular design of the fan regulator that is installed at your house, as a switch form. So it is a switch form and it's very small. If you compare it with the traditional types of fan regulators, then this is very small, compact, and very much handy, and it is power saving as well. So how this is power saving, how we get the advantage of this, we are going to have the discussion in this video. So first of all, this is the view, and this is something that you all know what this is. I don't have to speak again. This is fan regulator and you all know about this. Now let's move on to the next slide. So this is the beginning. Why I have named this slide as a beginning? Because if you look at this fan regulator, this is the traditional type of fan regulator. Okay, this is traditional type of fan regulator. Why I'm telling it traditional, conventional? Because this is something that used to be used in our old times. By rotating this, we used to control the speed of the fan. So this is something resembling to our past that we used to have. I actually, in my generation, I use this fan regulator. I know very well how to operate this and what this is. Maybe the new generation people, the new generation students don't know about this fan regulator. Then let me tell you, students, that this is the fan regulator that used to be used in our old times. If you ask to your any relative or your father or your mother, your parents, then they will tell you that what this thing is. Okay, so this is the traditional type of fan regulator. So just a small discussion on this, we will wind up this very quickly. So this is the traditional fan regulator. What are the fan connection? Let me show you before coming to the fan regulator and what is the working of this. Let me tell you the importance of fan regulator. Okay, tell you the importance of fan regulator. Now see, in your house, if you are regular to our channel, then you must be knowing. See, if you are regular to our channel, then I tell you that you will be very much good at electrical if you are regular to our channel, because in my every single video I tell you the electrical connections detail, electrical equipments detail, that is very handy and helpful to your daily electrical working, or daily electrical whatever you are doing at your home, or domestic kind of some general sense of knowledge that one should have. So this is your home connection, that is 230 volt 50 hertz, that is coming in form of phase and neutral, right? Now let's assume that you are having just a fan in your single room. Okay, and in this single room, two wires are coming, one is of phase and second one is of neutral. Now how you connect this wire? You are connecting, let's suppose you are connecting this wire directly to your fan. You are connecting this wire directly to your fan. Okay, so this phase is connected to this, and on the other hand you have the neutral. So on the other hand you have the neutral. So this is completing the connection. This is your fan, and this is working fine, okay, but this is working at full speed. So there is no control of the speed, and as we all know that there should be a control on fan speed, and for controlling this fan speed, what we have the fan regulator that is installed in between somewhere here, right? This is your fan regulator, FR, I am denoting it with FR. That is your fan regulator that is connected here, okay. This is connected here in series with your phase, in series to your phase, and in between the phase wire going to your fan, okay. Neutral is common, there is no need of connecting any neutral I mean to the fan regulator. Only in phase there are two connections that are required, and this is connected like this only, okay. So this is the introduction that how your fan connections are established at your home. So this is the basic funda, this is very basic electrical connection. Now let's make it a little more detailed. Now how the old regulators are working, let me tell you. This is one of the old regulator, as I said. Now what is the principle of working of this? Do you know one equipment or one device that is called resistor? Do you know, have you heard about this? If you have not, then just do not worry, we are here to help you only, okay. So this is the resistor, and the working of resistor, you do know what? If you are a science student, then you must be knowing the Ohm's law. That is V is equal to IR. That means voltage is always equal to the multiplication of current and resistance. So this is the resistance that I am talking about. Now R is depending on two parameters, V upon I. R is depending on two parameters, that is one is V, one is I, okay. So the value of R is decided by this. Now if you want to control your fan through this, then let me tell you, see how your 230 volt connections are going and how are the connections made in your rheostat or in your resistor at this fan regulator, the old fan regulator, okay. Resistance type. This old fan regulator is nothing but a variable resistance. That's why I'm explaining you like this. That's why I explained you the Ohm's law, okay. So these are four numbers of resistances. This is actually a variable resistor. Now let's suppose this is your phase, okay. Now how this phase is connected here, that you can see this is your phase that is going. This means this is your phase, or this is, you can say this is your button. If you rotate this button, this is your button, and if you rotate this, then this is going to be shifted to R2. This is again going to be shifted to R3, then R4, okay. If it is shifted here, and see where is the fan connection? Fan connection is at the end. That means here is your fan. See, if your power supply is coming from here and it is going like this, then it has to go through this R1, R2, R3 and R4. That means the resistances that are connected in series, the resultant resistance would be R1 plus R2 plus R3 plus R4. So that means the resultant resistance would be R1 plus R2 plus R3 plus R4. That means the total of all these four. Let's suppose the value of R1, R2, R3 and R4 is 1 kilo ohms. Okay, resistance is measured in the unit of ohm. Okay, and we are assuming these all four are of 1 kilo ohms only. then the total resistance would be in the circuit, that is 4 kilo ohm. That means okay, now I'm telling you all this, but you might be thinking that what is the resistance, what is the function of this. So let me tell you why I showed you this equation. The resistance is nothing but it is the obstacle, you can say in general layman language, it is the obstacle in the path of current. Whenever there is a current flowing in the circuit, if say I1 current is flowing in the circuit and if there is a resistance, then current would be resistance would give the resistance to the current to flow through the circuit. If the resistance is more, like our body, human body is having also a resistance that is in mega ohms. Okay, that is in mega ohms. That means something that is not allowing the current to pass through. It is nothing but resistance. That is, see, if I1 has to flow through this resistance, then this value should be less so that it can flow through this circuit. So if I hope the funda is clear now, that resistance is nothing but it is the opposing, it is the obstacle in the path of the current to do not allow it to flow through the circuit, okay, or to allow it to flow in lesser amount. Say if the resistance is more here, then the value of the current, see, resistance is more here, then the value of current I is depending on what? V upon R. See, if the R value is more, then I will be what? Less. If the R value is less, see here I show you, the value of I is equal to V upon R. So if the R value is more, then I value would be what? It will be less. If R value is less, then I value would be more. And see, if the I value is less, if suppose the I value is less, then what will be the speed of your, let's say this is the N speed of your fan, then what would be the speed of your fan? Then the speed of the fan would be less only, because it is not allowing the current to pass through the circuit. So there will be a lesser current, there will be a lesser speed. So this is how by resistance method we are reducing the speed of this fan. Okay, we are reducing the speed of this fan. So this is the one method by which we can regulate, we can control the speed of the fan. Same way, if we are varying this resistance value to R2, R3, this resistance would be cut down because it is now bypassing the R1 and R2. Let's I'm keeping this probe to the value R3, then my resultant resistance would be what? It would be R3 plus R4 only. It will not have any other resistance in the circuit. Only two resistance are in series, that is R3 and R4. Now if we are keeping R3 and R4, now if we are keeping this probe to the end of this contact, then there is no resistance. We are bypassing every resistance, and now the power supply is directly connected to the fan so that the fan can rotate at its maximum speed. Okay, it's rated RPM or rated speed. The fan that we are having at our home, the ceiling fan, that is nothing but induction type AC motor, right? Induction type AC motor. So now let's move to the next slide. Concept of the latest regulators. Now what is the concept of latest regulator? So this was something that we used to have. Now before going to the concept of the latest regulator, I will try to note down the disadvantages of the old regulators. Disadvantages. What are the disadvantages? The biggest disadvantage is that it is not that much of reliable. Not reliable. Why? Because due to the heating effect, whenever the entire current is flowing through the circuit, the resistance is putting the current down, dropping down the value of the current so that it will heat up. There would be some losses like I square RT losses would be there, and due to that the resistance are not more reliable. It is having a lesser life. That is why it is having lesser life. This is the one of the disadvantage. Second, the most biggest disadvantage is that it is not like that it is saving your power. Like if you want the your fan to move down slow, then you are not saving your power. You have to pay the same power to your fan. I mean, your electricity bill will not be reduced. It will be the same bill whether you run it on half speed or full speed, because you are like, if your fan is of 75 watt, and if you are running it at half speed of 30 watt, then it is not like you are saving 45 watts. You are wasting this 45 watts. This is what used to happen in the old types of resistor. This is in form of heat or in resistance. You used to have the losses. Okay. So this is what the biggest disadvantage is, not saving power. Not saving the power. So this is what the biggest disadvantage of this. Now we are coming back to the latest regulators. What are the advantages of this regulator? See on my screen, if you look at this very carefully, then by this small fringes you come to know there is something inside. I will also open this and show you what is inside, but before that I want to tell you about the circuit, that how it is working. So I tell you about the circuit of this here. See, there is a AC supply. Okay, there is a AC supply that is going through this. There is a resistor. I'm showing this resistor like this. I think this is okay. If it is not okay, then okay, let's make it like this. This is your resistor, but this is your variable resistor. Okay, this is your variable resistor. Now, okay, this looks quite messy. We show it here. See, this is your AC supply. This is your resistor. But this is your variable resistor, okay? Variable, that is I am showing this arrow in this. There is a capacitor. And there is one device that is called diac. What is this called? Diac. This is called diac. And this is connected to another device. This is connected to another device. That is called triac. Okay, this is called triac. Now in this, where is your fan? You will be thinking of, where is your fan? Okay, so you can keep your fan around here or here, anywhere, because both are same only. Okay, so here is your fan and this is your connection. This is how it is happening. Okay, so this is how it is connected, but it is not good to keep your fan here. Let's forget this. Let's keep your fan here, because your entire this circuit is outside of your fan, so I'm not keeping it inside. This is a short circuited and this is your fan. Okay, this is short circuited and this is your fan. This is your AC supply, that is of 230 volt, 50 hertz. Okay, this is your resistance, that is variable. Let's suppose this is your capacitor C, this is your diac, and this is your triac. Now two phenomena, I think three more phenomena is coming. In our previous in our previous fan regulator, we saw that there is only one resistor and we are varying the resistor, we are having the control. But in this we don't have the control like that. We are having one equipment or device called capacitor, one diac, one triac. Now let me tell you what is the purpose of all these three and how these three components are making it very much good for us. See, capacitor is that device whenever you are wearing this, see what is happening exactly. I want to tell you what is happening exactly. So then we will come back to this capacitor and resistor. This triac, first of all, this triac is the main hero of this, story or the entire, this fan controller. So what this triac is doing, triac is nothing but there are two anti-parallel, diodes connected, and there is one gate. This is one gate through which it is getting supply. What is the property of this triac? See, the property of this is like that. Whenever there is a knock on this gate, I am telling you in very general term. I am not using any technical term here. Whenever there is a knock at this gate, that is why this is called gate, because someone knocks, then gate is opened. Okay. So if somebody is knocking, then gate is open, and when this gate is open, then it is opening the path for flowing out the current from here to here. I mean, previously it was closed. When there is a knock on gate, okay, then this closed gate is open now, and when this is open, the entire current flows through this. Now we are controlling the knocking of this gate. I mean, we are controlling the supply to the gate. Gate is nothing but it is one terminal in this triac for making it in conduction mode. Conduction means making it in closed mode to flow out the current. See, you might have seen, or you must be knowing, that the supply that is coming at our home, that is of 50 hertz. 50 hertz means in 1 second there are 50 cycles, AC cycles, alternating current cycles are coming. See, these cycles are in this form. These cycles are in this form only. This is one cycle, 0, pi by 2 means 90, and this is pi, 180. Okay, if I am not wrong, I think I am wrong. Where I am wrong? See, this must be 2 pi. Okay, this is pi by 2, and this is pi, or I think this is 3 pi by 2, I don't know. This is 270 degree, and this is 90 degree, this is 180 degree, and this is your 360 degree. I hope the all 4 points are clear. This is 0, this is 180, and this is your 360. This is completing one cycle. I'm isolating this from the graph, then you better look at it. So this is your 360 degree cycle. That means 360 degree entire cycle. Okay, so this is the one cycle that is coming from this supply. Now see the beauty of this triac. Whenever you want to have the slower speed of your fan, then this gate will not knock this at this point. This will knock, or this will try to conduct, or this will on this triac at this position. Maybe this pi by 2. Let's say pi by 2. I am not feeling so much hot. Okay, I want lesser fan speed. Then this triac is on at pi by 2. So my cycle will start here. See my friend, the beauty of this. Then again this will be off. The gate supply will be off here. On, and then again this off, and then again at pi by 2 it is on. Sorry, at 270 degree it is on. So the one cycle that was previously of this entire, the supply that you were getting, that is of 230 volt, is not 230 volt now, because you are cutting down the cycles of your voltages and current. You are cutting down the cycle. That means by this method you are reducing the power consumption or power, you are saving the power. So this is the method, means you are controlling the voltage and current waveforms, you are controlling the conduction of the power, voltage and current cycles by using triac to control the speed of the fan. So this is also one of the method, and this is the method that is called that is used in the latest fan controller. So I hope the concept is clear now. Now let me tell you what is the use of this capacitor and resistor. I am showing you a different circuit for this. See what is happening here. This is your circuit. I am showing you only half circuit. This is your capacitor. Okay, I am showing you half circuit. Now if I connect the voltmeter here, see what is happening. And I will also tell you the importance of this diac. See, both are looking alike. I mean, this triac and diac. Only the difference of this gate, there is one more terminal. There are 3 terminals in triac, and one of the terminal is gate. This is first terminal, this is second terminal, and this is the third terminal, that is gate. But in diac there are 2 terminals only. This is the one terminal, this is the second terminal. In diac there are 2 terminals only. This is the one terminal, this is the second terminal. Okay. So now, before I tell you the importance of the diac, actually diac importance will be very clear after this. Diac operates at particular voltage, like if you are having a diac which is having a voltage rating to operate above 1 volt, then at 0.9 volt till 0.99 volt it will not be conducted. So unless and until it is having 1 volt, then after it is getting conducted and passing the electricity through it, and allowing the electric current to pass through it. Okay. So same way here, see the capacitor and this resistor. So the capacitor charging is dependent on resistor. If the value of resistor is more, the capacitor charging is less. Okay, it is taking more time to charge. See, time is relevant to this waveform. This time is not like in hours or in seconds. This time is in milliseconds. Very less. So if the resistance value is more, the charging time is less, and when the charging time is less, then it will take more time to reach to, like, let's say the diac conduction, conduction voltage is 1 volt, then the capacitor is taking up to pi by 2 cycle to reach to what? To reach to 1 volt. And when it reaches to 1 volt, then this strikes. The diac starts conducting, because diac is directly connected here. See, diac is directly connected here, so that it starts conducting. Okay, so that it starts conducting. Now let's suppose the resistance value is less. The capacitor charging is more fast, but it is in terms of frequency. So if its charging is more fast, then it is shifted somewhere here. If we are keeping resistance value is very less, we are setting it something like it is now getting charged at 0. I mean 0 it is charged, then the diac will be full time conducting. And if it is full time conducting, then the triac that is connected next to the diac will be full time conducting. So the cycle will be full, and the cycle is full, then your fan speed will be full. You are operating the fan at full speed. So this is the phenomena, this is the concept, how the fan regulators are working. Okay, how the fan regulators working. So this is the technical phenomena. Now it is the time to represent you what is inside that fan regulator. See, these are two images. See, this one looks in red, that is nothing but your capacitor. This blue part, that is nothing but variable resistor. Variable resistor. That means in the entire circuit, see, these are supporting equipments. These are supporting equipments used for controlling or making the circuit complete. So it is a different thing. Company by company, it depends and varies. But the main components I am telling you, this is the capacitor and this is the variable resistor. There are diodes and triacs that are installed here, but we are not able to see. Okay. So now the main component that is in your hand by which you are, making the speed or controlling the fan speed, that is your variable resistor, that is in your hand. So this is in your hand, like you are rotating this, knob. What you are doing? You are varying this resistor, and when you are varying this resistor, then the entire picture is now clear in front of you, that what is going to happen in your circuit and how you are controlling your fan. So I hope the concept is clear now in your mind, and I hope I have this is solving your purpose and this is solving your curiosity as well, that what this thing is and how it is working. So let's close this video with this. Let's meet you in another video. Till then, take care. Goodbye. If you like, then please like and subscribe this channel. Thank you. Yeah.